Okay, so today we're doing 11.6. That's trigonometry and area. So we're going to be finding area of regular figures and areas of different types of triangles. Triangles that aren't right triangles given different measurements. So today's probably, I think, out of all the lessons in chapter 6, or 11, I think today's is the most difficult. And that's why we spend 2 days on 11.6. All right? This is the last lesson in the chapter. You'll be doing your chapter test next week, next Wednesday. Okay, and then we'll be on to chapter 12. We'll probably pause for a brief couple days or a week, or actually probably about a week while you guys are doing the SBAC. So, woohoo!
Finals, though?
Yes, still have finals. We'll talk about that later. Okay, so we're going to copy and label the parts of a regular octagon. It's on page 573, but since I had you not get textbooks today, I'm going to actually put the picture up here for you. Yes, it's pretty special.
Okay.
I did not draw it myself. However, I did copy a textbook myself.
Looks pretty swell.
Yeah. So those are the different pieces that we need to have copied down and defined, and then the area of a regular anything, any regular shape, is area equals 1/2 AP. So this works for any regular polygon.
Can't draw an octagon to save my life. Octagon, stop making fun of my lips.
Time copying this down, page 373 of your textbook. That's where you can get these things. Okay? Or I'll hang this on the board. You can get the definitions later if you like. All right? Here we go. We're going to move on. We're going to try now problem number 1. We're going to use our formula. All right? So I'm going to zoom in there. Example 1 off our assignment. You're going to need a clean sheet of paper for sure. Okay? Just find the area of each regular polygon. Give your answer to the nearest 10.
I got you.
So I'll zoom right in there.
No.
Start out with area equals 1/2 AP. So tell your neighbor, help work together and find out what A and P are in this. Okay? Okay, what is A? Yes, JJ. You're right, it is the apothem. Okay, so JJ, I'll give you another shot. What is A in this problem?
Oh, 6.
Yes, good job, JJ. It is 6. Okay, so we've got A equals 6. So these are the two things we need, right? We're looking for area, so to find that, we need to know A and P. Do we know P?
Almost.
Yes, Hannah.
6.
P is not 6.
Sorry.
Yes? Andrew? Yeah?
The perimeter is 36.
36, holy cow, how'd you get that?
What it was is from the center you created a 30, 60, 90 right triangle.
Okay.
And then since the apothem is 6, and which is also equal to 2x.
Okay, can I pause you for a minute? How do you know this is a 30, 60, 90 right triangle? I think I know how, I just want everyone else to know.
Because all the angles are equal to 120, and when you divide those in half, they're equal to 60.
Okay. The other way to think about it is each one of these little triangles, you can make 6 different triangles, right? Because there's 6 sides. And each triangle is equilateral. Okay, now we could go through that and prove that, but that means these angles are equal, meaning that each angle here is 60 degrees, and that makes this 30 degrees. Okay? Now Andrew went the other way. He said there are a total of 6 interior angles, right? And you were saying the sum of the interiors. What are that?
The sum?
The sum. So how did you know that one of these is 120?
The degrees?
Yeah.
180.
180?
Oh, those?
Yeah. 720? And so is 720 divided by 6 120? Okay. So, and that's where you were going with it, right? So this was 60. I tend to like to think of it as I'm breaking these up into little triangles. So, for instance, I know we're not on this problem, but when I move to number 2, and I'm trying to figure out what an intercepted, not an intercepted angle, but what this interior angle is, right here, there's 8 sides, so if I go 360 divided by 8, that ends up being 45 degrees. Oops, not percent, degrees. Unbelievable. Okay? JJ?
Isn't the perimeter not 36?
I haven't got to the perimeter. We will get to that, though. Okay? So, right here, we've got 30. We've got 60, meaning this is a 30, 60, 90 triangle, meaning that this length right here is what, Andrew?
X.
You said this was x, okay? And this is 2x. We really don't need that, but that doesn't make this 36, unfortunately. Okay? Go ahead, Jordan.
Wouldn't the radius be 12 root 3 over 3, making the perimeter 72 root 3 over 3?
Well, so you're saying that this side is...
Because wouldn't that be x root 3, and then...
This is x, right? So this is x root 3.
Yeah.
Very true. Okay?
Oh. And then can't you use that to find that and multiply by 2?
You could. Now, you could use special right triangles. There's a little easier way, I think, to do this, though. Think about what we've been doing this chapter when we're given an angle and a side and we want to find another one.
Oh.
Lee?
For this one, you can use the tangent.
Okay, yeah, you can use the tangent. We have the adjacent and we have the opposite of 30. Okay? So our perimeter, really, how many x's are there here around the edge?
12.
Yeah, there would be 12. That's an x, that's an x. That means each side would contain 2 different x's.
72.
Okay, if you think of that. And so that's 12 x's all the way around. All right? If you want to think of that whole length as 2x, that's fine. But I'm just going to write 12x here for a minute. And the reason I'm doing that is because I'm trying to find things that I can plug in here. So for those of you that are cranking away right now and trying, please leave a trail of your work. It's going to be very difficult for you. Otherwise, it makes this chapter very difficult. Our apothem is 6, so I'm going to plug that in right here. Our perimeter, our perimeter right now is 12x. Now that gave us another variable, which is x. And Lee just told us that we could actually find this right here because it's the opposite. There's the adjacent of 30. We could say the tangent of 30. So you're going 12 times the tangent of 30. So think of it that way. Tan 30 is equal to what over what? X over 6. Okay? And so what does x equal?
6, 10.
6 tan 30. Now everyone do 6 tan 30 on your calculator. Do you get a whole number?
No.
No, sometimes you will, but you didn't that time. Okay, so if you don't get a whole number and you're plugging it in, should you just round? No, you should put the exact value, and this is the exact value. So if right here, I should have given myself room. This should be 6 tan 30. I should have also used a pencil, but I don't have one here. All right. 6 tan 30. All right, just so we can read that a little better. It's 1/2 6, which is our apothem, times 12 times x, which is 6 tan 30. And that's, you put that exact thing into your calculator. If you want, you could just multiply all these things out. If you don't want to put that exact thing in, you can say 1/2 of 6 is 3, 3 times 12 is 36, 36 times 6 is whatever it is.
So area is 6, 10, 30.
No, the whole area is this.
Oh.
Yeah. Anyone multiply it out?
Yeah.
Right there, JJ, quick on the draw. 124.7. That's what I've got too. Yeah. Yeah, he didn't, but we're going to give it to him there. Square centimeters. Well done, JJ. Okay. How do you think you got it? That's tough, man.
Yep.
It's a lot of math. Any questions on it?
Why couldn't you just, after you know how you got the, when you did the 30, 60, 90?
Yep.
Well, so 6 equals x root 3, right?
You could have used special right triangles here.
Yeah.
Yes, you could have.
And then you could have said that each side is 12
Yep.
and multiplied that by 6.
You could have right here said x is equal to 6. Well, 6 is equal to x root 3. And then you could have solved for x and put that here and multiplied it by 12. You could have. The only reason I didn't do that is because I know what you're practicing today.
Okay.
And you're not going to have special right triangles most of the time. Okay? But you definitely could, yeah. There are sometimes a lot of ways to solve the same problem. Any others? Okay, everyone try number 2. Work with your groupies. Oh, hey, it's going to be random. Person number 16. Give me what A is, person number 16. Where you at? Next, number 16 is Riley. Riley, where you at? Riley. A is 7. Well done, Riley. Way to step up to the plate. All right. P, person number 10.
Well, I just sort of realized that I just did it wrong because I was thinking 45, but I would have to divide it to 45 in half, so now I'm like going back to square.
Jordan, if I call this X, what is my perimeter?
It would be 16x.
16x. Very good. Thank you. Okay. And, right, person number 22, what is our angle right here? Breathe. That's you? What's this angle? It is not. Person number 29, we don't. Oh, JJ.
29, the angle is 45.
That is not. Ryan. 22.5. Yes, guys, this angle's half of the big angle, right? That's 45, so this is 22.5. So we're looking at this angle, 22.5 degrees. Man, I'm not going to have room right there. Let me draw it in here. Got to use sound effects. It makes it cooler. All right, 22.5 degrees. How are we going to find what x is? We're using our formula a equals 1/2 AP, and we plug in our a, which is 7, and our p is 16x. We're left with that one variable of x. Okay, 1/2 times 7 times 16 times our x. How are we going to find that? Gracie? Yes.
You have to do the tan for so you know that 7, which is the adjacent, and then you know that angle too.
Okay.
So then it would be tan 22.5 equals 7. Oh wait, x over 7, and then you multiply it by 7. So then it'd be 7 tan 22.5 equals x, and then you plug that in for x.
Nice job. Okay. So 7 tan 22.5. That's equal to x. Oops, that was x. Okay, so just so we're clear, we've plugged A, we've plugged in P, we've plugged in now for x this. That's why we have those parentheses, so that we can see where we plug things in. And now we're multiplying out. Multiplying that out, Catherine. 162. Okay. 162.4. How many agree? Well done. Okay. Any questions? Everyone rate themselves 1 to 5 right now. Okay, can I get your attention back up here? Let's talk about a few of these just real quick. Hey, number 4, I think early, actually, let's move on. Let's check out number 5 first. Okay, I think earlier when we were talking about 1, I may have said equilateral when we broke these up. And I meant isosceles. Okay, this is an isosceles triangle. It's not necessarily an equilateral triangle. Okay, so when you're looking at, say, number 5, you're drawing this in. Now remember, when you draw in that, if you draw that in, this is 10 and that's 10. If you draw in your apothem, please don't confuse yourself thinking that that's 10 because the 10's right on it. You just drew that line, right? So you may want to draw your apothem somewhere else. But this side length is not 10. It doesn't have to be 10. All right? This right here on number 4, this is an equilateral triangle. And when you draw in, say that, and I'm going to draw it there so it doesn't look like it's 5. But when you think of this, this is 60, and this is 60. If you were to break your different triangle pieces, your triangle into 3 different triangles, so this one here, and this one here, each one of these is 120. That makes this 60, and that makes this 30. Okay? And you can use special right triangles. That's 5, which is a length of 2x, and that makes this x, which is 2.5. You could also use tangent there, or sine. You could use any of them there, depending upon which angle you use.
And then when you go to play
Okay. Are there other things that I can clarify up here?
So
I didn't mean to say equal. If I said equilateral up here, that's not. I think I did. So I could check the video replay. I think I will.
7.2.
Okay. Yeah. Hey, I do want to move on. I want you guys to move on down. Example 2 is very similar. Okay. Doing the same thing. All right. Example 3, though, is much different. So let's take a look at example 3. Number 10 says, find the area of each triangle, give your answer to the nearest tenth. Okay? So I want to work on number 10 and number 11 with you. Okay? So let's check out number 10 there. How do you find the area of a triangle?
Base times height.
And, yep.
Base times height divided by 2.
Base times height divided by 2. So area is equal to base times height divided by 2, or another way of saying it is 1/2 base times height. Everyone agree? Now I will, thank you. I will tell you that we're not using that formula in that form today. You're going to have a new formula for area of a triangle. Is the problem with this triangle? What's the problem? Lee?
You don't have any height or base.
You don't have any height or base. Okay, well, yeah, I guess you can have any base. I mean, these two could be bases, but we don't have a height. You need a right angle height. Okay, so when you start thinking about this picture, you could actually, I mean, if you take a right angle and just kind of, like we did earlier in the year, and just kind of draw or slide that right angle until it hits the other angle, so maybe right about there, you could say, okay, well, here's my right angle, which is, that's my actual height. There's my height. Okay? That's my height. But I don't know that measurement. Like, I could calculate it maybe if I called it x. How could we do that height? Talk with your neighbor real quick. How could you do that? Okay, person number 4. Andrew, what do you think?
I'm not sure.
Not sure? Volunteer? Really?
Tangent?
You could use tangent. Could we use the Pythagorean theorem? I heard that a lot.
No, because
No,
it's
like
the
7
dropping the altitude is making the 7 not be able to.
Yeah, if that was y, it'd have to be like 7 minus
Good.
y.
This whole length is 7, not just this.
Yeah.
Okay, so we could use tangent, or not tangent.
Yeah, opposite and I thought
Because you're
oh,
trying to find for x.
sine. I mean sine. No wait.
We're
Yeah.
trying. So we're
Sine.
given
Sine.
opposite and hypotenuse.
Sine.
Okay, so we could figure out the height. We could say the height is actually equal to. So this right here, we're saying that's x. So if we want to calculate that, we could use sine, right? We could say sine of 31 is equal to x over 7. Opposite over hypotenuse. So we 7 sine 31.
Equals x.
Okay, how many are with me right now?
Yep.
That is equal to our height. So usually we need to know the base and we need to know the height in order to figure out an area. We now know the base. The base is 7. This big 7. Everyone agree? Like if we turn that, oops, 7. We know the height. The height is
3.6.
7 times sine 31. So we can put all this in. It's equal to 1/2 7 times 7 sine 31. How many are with me?
Yep.
Okay, there's your formula right there. I want you to figure out how you can rewrite this using this without base and height, having to calculate the height. Like, if I want to do, let me rephrase that. Without doing any work, let me ask a different question. Without doing any work, I want you to write how you're going to find the area. Take this triangle down to this part without doing any other work. Just looking at patterns. Work with your group. Okay, hey, where do I see the 7? Yeah, it's one of my sides. Where do I see that 7? Okay, ignore the right triangle now. It's just the other side. Sine 31. Where do I get the 31?
Angle.
Angle. Included in between the sides. So, what is this one going to be? Area is equal to 7 times 10
Times sine 44.
times sine 44.
Wait, where are you getting the
What am I missing?
1/2?
1/2. We need the 1/2 in there. How many see the pattern?
No.
Look at where the 7s, 10s, and 44s are. Okay, I want you to look at 12 now. Number 12. By the way, for those of you, look.
Oh, that problem.
So really, we could have, it doesn't matter what order those are in, but based on the picture we have there, this would be my height, which is 7 sine 44. Everyone with me? Okay, I want you to write the area of this one using that same pattern. Emily, what do you think?
She's calculating.
Would it be A equals 1/2 h times 6 times sine 61?
Is that right? How many got that? 1/2 8 times 6 times sine 61. That is right. The formula you're using here, good job, is area equals side 1 times side 2 times the sine. Oops, I forgot 1/2 in here. Again, I always do that. Unbelievable. That's ridiculous. 1/2 times all this. Darn 1/2. Okay? Sine of the included angle. And so I'm going to put included angle in here. That's a big deal. The angle has to be included between the two sides. So if it was this angle and those two sides, that doesn't work. Right? The only reason we can use that is because it's opposite over hypotenuse, opposite that side. So in this one, I drop my altitude right there. There's my height, opposite over hypotenuse. Okay, so once again, really if we're using that idea, those two numbers would have been switched. But you can multiply in any order, so that really doesn't matter.
Okay.
Everyone have it? All right, man. There you go. Your assignment's the example side. Make sure you're asking me questions if you have them before you